Oh man, I'm just trying. I'm like tackling all the most difficult concepts to articulate and explain, like my major findings in understanding as I've understood deep learning more and more. One thing I have to point out is one of the miracles of, I'm talking about the convolutional neural net architectures, is that by learning these filters, which are kind of like motifs of the data set, they're filters which are able to detect things which commonly come up in the data set, in a sense. Especially as you go to the deeper level filters, where you have filters which can go and detect entire objects like a face, or because they learn these common features that exist in the data set. And it's kind of, the way they describe it is they learn an efficient representation of the data, because they learn to, they grow these filters which represent common objects in the data set, and then they use those filters. Basically, a new image comes in and you can tell which kind of filters it activates. And that, because it's like, assuming it's from the same data set, if it is a regular image that is part of the data set that it's been trained on, these filters will be useful to represent that. There's a type of network called an autoencoder. Historically, it was like a way for like dimensionality reduction with a regular multi-layer perceptron. You can send, it basically acts like a little bottleneck where you can send in the high dimensional input, like an image or a really high dimensional vector, and then it kind of compresses down into layers that have smaller and smaller numbers of neurons. And so it's kind of like when you compress it down, and then it kind of mirrors that structure on the way out, so it kind of gets larger. You can compress that high dimensional input down, and you are getting rid of some information, but you're making a smaller, a lower dimensional packet of information, like a smaller vector, which is representative of what that input was, because it was just transformed by the weights of that network. It was just kind of transformed by that into a smaller package, and the weights represented it, helped to represent it in a way which makes sense. So what's interesting about the convolutional neural nets is that it's able to achieve something which, to my knowledge, it was not ever possible before, which is the ability to then go in reverse and start from that lower dimensional, lower information package, and then put it backwards through the network and recover something which would correspond to that. And the reason why this was not possible before is because if you think of, it's so hard, if you're familiar with like PCA or other any kind of dimensionality reduction algorithm you want, what happens is that you are literally tossing information away that can't be recovered. The process of dimensionality reduction is irreversible, in the sense that it's like, well, in the simple case with like PCA, it's like you multiply that high dimensional input vector by a matrix, and that converts it, it transforms it into a smaller vector. And when you if you were trying to map that back into the original space, it won't work. Basically, you can map it there, but it won't occupy a volume in that larger space anymore. Like, for example, if you I tried this. If you take a 3D vector and you do PCA and reduce it into 2-dimensional, if you then take that and then try to map it back up in the same way by multiplying it through a matrix again, you'll map it back up into a 3-dimensional space, but it will be a plane. Like, the points will lie on a plane. So there's no way, in a sense, to recover that information once it has been lost through dimensionality reduction. So what's so novel about what convolutional neural nets can do is that it for the first time is sort of able to do what before was kind of impossible. Of like, you can take the lower dimensional representation, like you take the piece of information that was the vector representation after it's been kind of bottlenecked down through the network, and you can change something about that representation. You change the number a little bit basically, and then you can actually map that back up into a full image. So I'm going to try and make it concrete. So basically, if you had an image and you send it through your convolutional neural net and it was transformed into like a vector basically, which represented how much each of some, deeper level like filters were activated or something. You change some of those numbers, it's possible to actually send it in reverse and wrap it back up into an image and see what would correspond to that new representation. You modified the lower dimensional packet and you mapped it back up. And so how does it able to do that is basically it stores some information about the data set in the filters. So it kind of, you've tossed away information, but you've also saved information about what kind of motifs exist in the data set. That information that you've stored is what allows you essentially to recover another, like a higher dimensional object, namely the image that would correspond to that lower dimensional vector that you modified.